Hello, explorers. I'm Hailey. Have you ever looked up at the night sky and wondered why it's mostly dark, even though there are billions of stars out there? It's a cosmic puzzle that has fascinated humans for centuries. So get comfortable, let your curiosity take over, and let's dive in.
All right, let's just jump right in. We're going to talk about something you feel every single second of every day, gravity. But we're going to flip everything you think you know about it on its head. It turns out it's this beautiful, totally mind-bending illusion. So, to start, I want you to think about something you've seen a million times. Something so normal, so everyday that you probably never even questioned it. It just is. You know the drill. You drop your keys, your phone, maybe a glass of water, whoops. And what happens? It falls straight down every single time. It's like the one rule in the universe you can always count on, right?
But here's the question that's going to change everything. Is that object really being pulled down? Is there some invisible rope, like a tractor beam, yanking it towards the center of the Earth?
Okay, but what if there's no pull at all? I mean, what if that thing you dropped is just following the easiest path? What if the very shape of space around us is what's pushing it to the floor? Yeah, I know. Let's break that down.
So how in the world do we wrap our heads around an idea that huge? Well, we're going to use a really simple analogy. Think of it like a cosmic trampoline.
Okay, picture this, a giant trampoline, stretched out perfectly flat. You put a little marble on it, and nothing happens. It just sits there. But now, you take a big, heavy bowling ball and place it right in the center. The trampoline fabric sinks way down, right? It creates this big dip. Now, you roll that marble near the edge. What's it gonna do? It's gonna spiral right down that curve, straight towards the bowling ball.
And here's the key thing, the big takeaway. The bowling ball didn't pull the marble. There was no invisible string. All it did was change the shape of the surface the marble was on. The marble was just following the curve. That's it. Okay, so that's our trampoline analogy. Simple enough, right? Now let's take that idea and blow it up to the scale of the entire universe. Because here's the wild part. That cosmic trampoline, it's not just a cute story. It's kinda how reality actually works.
Yeah, that cosmic trampoline, it has a real name, space-time. This was the genius idea from Albert Einstein. He realized that the universe is made of this invisible fabric. It's got the three dimensions of space we all know, up/down, left/right, forward/back, but it's woven together with a fourth dimension, time. And because they're all connected, when you bend space, you also bend time. Mind-blowing stuff.
So this really lays it out, doesn't it? The old way of thinking versus the new. On one hand, you have this idea of gravity as an invisible force, like a magnet, just pulling things. But the reality? It's so much cooler. Gravity is just what we feel when we move through the curves of spacetime. It's not a force, it's just geometry.
Let's break that down for a second. Think about Earth. It's massive, right? So it creates this huge dent in spacetime. And us, we aren't being pulled to the surface. We're actually just trying to slide down into that dent. The only reason we don't is because the ground, the floor, is physically in our way, pushing back up. The shape of space itself is trying to funnel us down.
Okay, now that we have this powerful new way of seeing things, we can finally tackle one of the biggest myths out there. You know, the whole zero gravity thing with astronauts floating in space. Yeah, that's not what's happening at all.
Check this out. This might actually blow your mind. Up where the International Space Station is orbiting, Earth's gravity is still about 90% as strong as it is down here on the ground. Seriously, it is nowhere near zero. So, if gravity is still so strong up there, why are they floating around like that?
The answer has a really cool name, free fall.
See, the astronauts feel weightless for the exact same reason you would if you were in an elevator and the cable suddenly snapped. Because they are, in fact, falling, constantly.
Here's how it all comes together. The station and everyone inside it is constantly falling towards Earth, right down that big space-time dent we talked about. But at the same time, they're zipping sideways at over 17,000 miles per hour. So as they fall down, the curve of the Earth drops away from them at the exact same speed. The result? They just keep missing the ground. They're in a state of endless falling, which we call an orbit.
All right, so we get it for things falling on Earth, and we get it for astronauts in orbit. Now, let's pull the camera way, way back.
Let's see how this whole beautiful dance of geometry shapes our entire solar system and even the whole cosmos. It's pretty simple, really. The bigger something is, the deeper the dent it makes. Earth makes a nice little dent, and that's what keeps the moon circling us. But then you got Jupiter, way bigger, so it makes a much, much deeper dent. And the sun? Oh man, the sun is so massive it creates this enormous valley in space-time. All the planets, including us, are just rolling around the sides of that giant cosmic valley.
But what happens when you get something so heavy, so dense, that it doesn't just make a dent or a valley? What happens when you get something so massive that space-time just can't handle it? Well, you get the most extreme example of all, a black hole. This is an object so incredibly dense that it doesn't just bend space-time, it tears a hole right through it. It creates a bottomless pit where the slope is basically infinite. It's so steep that absolutely nothing can escape its pole, not even light. So when you think about it, it's all connected. A planet going around the sun, an apple falling from a tree, an astronaut floating in space, they're all doing the exact same thing. They're just following the curves of the universe. The whole cosmos is just this beautiful, chaotic dance of pure geometry. So really, the next time you drop something, just for a second, remember what you're actually seeing. It's not being pulled. It's sliding down the invisible, curved fabric of the universe itself. And that leaves us with one last really trippy question to think about. We know gravity bends space. So what does it mean that it also bends time?
The universe is massive, but understanding it doesn't have to be overwhelming. Be sure to hit that subscribe button so you never miss a journey. I'm Hailey, and until next time, keep looking up and have a peaceful night.